Alright, for the second video on graphing quadratic functions in standard form, we're going to take a look at graphing those functions that do not have y equals 0 as the line of symmetry. We're also going to be calculating the vertex of a quadratic equation in standard form. And to calculate the vertex, well, to calculate at least the line of symmetry, we're going to be using this little formula. So we're going to take x equals the opposite of whatever b is, and that's going to go over 2a. So that's how we're going to calculate where our line of symmetry is, and that's also going to help us calculate our vertex. So we're going to need to remember that. And just as a reminder, you should be using pencil to take your notes. So if you need to stop the video and go find yourself a pencil, that would be great, because you're going to be graphing a couple of things, and of course graphing can present some challenges, so please have something that you can use to erase. Now, just as a reminder, the whole idea here is we're going to be graphing by hand in this particular set of notes, but we are going to be using our TI-83 calculators soon. But it's a good idea to understand how to graph and what all these parts of the function mean. So just recall that A, B, and C represent numbers. A and B are going to be coefficients, C is a constant, and also C is going to be where the graph hits the y-axis. And so that can just be remembered as the y-intercept as well. So where the graph hits the y-axis. Sort of like, remember from Algebra 1 when you were graphing y equals mx plus b, b was the y-axis intercept. So C in this case is going to represent the same thing. Well, in example number 1, we want to use the standard form of the quadratic y equals ax squared plus bx plus c to determine what it can tell us about the graph. So just by looking at the function itself, we should be able to see what's going to happen with our graph when we actually do start graphing it. In this case, in each case actually, if a is larger than 0, then we're going to realize that the graph is going to open upwards. And therefore, we have the vertex as a minimum. So in this first case, we're going to say that the vertex is a minimum because it's the lowest point of the graph. So if we take a look, whatever they figured out, whatever the function is, and it's not given here, but x is going to equal the opposite of b over 2a, and that happens to be 2 because x, actually it's actually negative 2, isn't it? Because if you take a look at where the vertex is, it is this line of symmetry that it runs through. So the line of symmetry, x equals negative 2, also has the vertex on it, and that's going to be the case every single time. So the line of symmetry also is where the x value is for the vertex. And again, we can see here that this is the minimum of the graph. The graph does not go any lower than that point. And in the second case, when a is less than 0, then the graph is going to open downward. And the vertex will be a maximum. So if you take a look at the graph here, the point where the vertex is, none of the graph goes higher than that point, does it? So it looks like here we have x is equal to 2 for our line of symmetry, and also the vertex has x is 2 in its ordered pair. We're not sure what the function is here. We didn't give the function for it, but just looking at the graph of the function, you can see that the vertex has to be the maximum. So in this case, when a is a negative value, so when a is negative, then we know that the graph is going to face downward, or it's going to open downward. If the in case 1, we were saying that if x is greater than 0, so if x is a is a positive number, this coefficient in front of that term x squared, then we know that the graph is going to open upward like this. Okay, if we're still considering the coefficient a, the child graph will be wider. That means that it's going to open a little bit larger than the parent graph y equals x squared if the absolute value of a is less than 1. Okay, so that basically here is going to be if a is a fraction. So if a is a fraction, the graph of the child function is going to be wider. And then conversely, the graph will be more narrow if the absolute value of a is larger than 1. Okay, and again, remember absolute value just means that the number has to be positive coming out of there. So whether the a value is a negative or not, it doesn't matter. As long as it's a fraction, in this case, less than 1, then the graph will be wider. If the absolute value of a, whether it's negative or positive, remember the absolute value means it's going to be positive, it's going to be larger than 1, then we know that the graph will be more narrow than the original parent function. So if I can give you an example of that, if the parent function looks like this, okay, then when we have something that looks more like y equals 3x squared, it's going to end up being a more narrow graph like this. And you may remember that from some of the examples we've done in previous notes or even in your classwork, in your assignments. So let me give you just a couple of examples. If y equals 1/2 x squared, you're going to get the wider graph, and let me just show you the wider one would be more like this, where it's, larger. I should be going right through the origin there, but of course it's a little bit difficult on my iPad that I'm using. The other one, just another example, y equals 2/3 x. So anytime we have a fractional coefficient for a, we're going to get that wider graph like the black one that I've shown here. And even if the even if the coefficient is a negative 1/3 x squared, you're still going to end up with a wider graph. And then conversely, we see that y equals 3x squared gives you the more narrow one, this red one on the graph that I've sort of given as an example. Even if you have 7x squared, that's going to be much more narrow. What if you have negative 14x squared? That's also going to be more narrow. Just remember that that one's going to be a downward facing, but it's definitely going to be more narrow than the parent function. And the parent function on this example one is the purple one. Okay, so I made that one, that's the y equals x squared. Okay, let's take a look at C. C is the constant term. It's not the one with the variable, but it's the last thing. And remember, that's going to be the y-intercept. Okay, so it's going to be where the actual graph hits the y-axis. So for example, it could be at 0C. That's going to be our y-intercept. And you want to remember these because we're going to be asked to find these things in the next couple of examples. And to find the axis of symmetry, we're going to be using that little formula that I wrote at the top of the page, x equals negative b over 2a. So to make some sense of that, just remember that we have an a in front of our x squared. That's the a that we're talking about. We're going to plug that in. And we're going to take the opposite of b, whatever that is, and plug it in here. So if this is a positive, this is going to end up being negative b. And if this is a negative b, then this will end up being a positive b. And then we're going to have our c. The c is not going to help us figure out the axis of symmetry, but we're just going to plug the things in that we see, the coefficients in front of those two terms with the variables, and we will find our axis of symmetry. And then to find the vertex, we're going to actually the vertex is going to be an ordered pair. We're still going to be using our little formula that we use to find the axis of symmetry, but this time we're going to take and find out our y by plugging in the x value. So whatever we get, we're going to plug in the x value that we got when we did our axis of symmetry work, and plug it into the equation and then simplify. So those are just a few of the things that we can use to see how the graph is going to look. And these are some terms that you need to be familiar with in order to continue on working with these quadratic functions. All right, on the back side of your paper, we are going to take a look at this function right here, y equals 2x squared minus 8x plus 6. So it looks like we first of all have to identify a, b, and c from this function. So a is going to equal 2. It's the number in front of the x squared term, and that's our coefficient for x squared. And then b is going to equal negative 8. Remember to use the operation symbol in front of there as well. That's going to be part of the value that we use for b. And then c, our constant, is 6. Part B in this example tells us to tell whether the graph opens up or down, and that's just a simple fact of, is a greater than 0? If a is greater than 0, which we see that it is, then this means that it opens up. It's going to be a positive graph. It's going to open upward. Okay, and then we also need to find the axis of symmetry, and in this case we're going to use our little formula that we have. And all we have to do then is plug in the b value that we have as well as the a value. So I'm going to say x is equal to negative 8. Okay, so negative 8 is just positive 8. And then 2 times 2, because a is 2. And so we have 8 over 4, and x is going to equal 2. So the line of symmetry is x equals 2. So when we get ready to graph this, we can actually add our axis of symmetry at x equals 2. And part D is asking us to find the coordinates of the vertex. So now that we know x equals 2 for the vertex itself, we can just plug that back into the entire function. So we're going to plug x equals 2 in, and here we go. So we're going to try to find our y value, because the coordinates of the vertex are going to be an x and a y value. We're going to actually have an ordered pair. So 2 times 2 squared, all right, we're plugging it back into our original function that we were given, minus 8 times 2 plus 6. So now I just have to do good math. Of course, order of operation counts here. 2 squared is 4, times 2 is 8, minus, and we have 8 times 2, which is 16, plus, 6. And so that actually equals negative 2. So if we go to write our vertex, the coordinates of our vertex are going to be 2. Remember our x value, what we used when we got the formula over here, and then our negative 2 came from working it out in our function. So now we know where our vertex is, we know what our axis of symmetry is, we also know that our graph is going to be opening up, and we also need to find the y-intercept, and basically our y-intercept is just taking the c value, 6, and putting it with a 0. So the y-intercept is going to be 0, 6. This is our c value. Remember, c is the term without the variable in it. All right, and then now that we have all these things, we're going to go ahead and sketch the graph. I've already drawn in the x equals 2, which is our line of symmetry, so we know that half of the graph is going to be over on the left and half of the graph is going to be over on the right. So all I have to do now is plot my vertex. My vertex is at 2, negative 2. So I can go ahead and put a dot there. I know that my y-intercept is at 0, 6. Now if I have a point at 0, 6, then I also have a point equidistant from the line of symmetry on the other side. So that's going to be right over here, because I have 2, right? This is 2 units from the axis of symmetry. If I go 2 past it, and you guys might remember something like this from geometry last year when we were doing the reflections, and now I can just say, well, my graph is going to go from my vertex upward through this, and I know that's not a perfect line, a perfect curve, but you get the idea that it should go through this point right here because that's the y-intercept, and then of course we have this point over here because it's a point symmetric from that y-intercept. and of course our minimum value at 2, -2, which is our vertex. And for example 3, we have this function right here. And again, just looking at the things that we have in the function, we can start thinking about how the graph is going to look. It asks us to identify A, B, and C. If we look at A, it's the value in front of the x squared. And there's not a number there, but of course it's going to be -1, because if there's no number, then we assume that it is 1, although this has a negative there. So B is going to be 6, and C is going to be 1. Each of these values is going to help us find out more about the graph. So as long as we can pick out the A, B, and C, we should be pretty good about finding out the other things about the graph. Okay, so which way is this going to open? Is this graph going to open up or down? Well, that's based on our A value, and A here is equal to -1, and remember, if any number, if the coefficient is less than 0, then the graph is going to be a downward facing graph, a negative facing graph, and we're going to have a vertex that is going to be our maximum value. It's going to be the highest point on the curve. And to find the axis of symmetry, we're going to use our formula, -b, or sometimes we call that opposite b, over 2a. So if I fill in the things that I know, here's my b. So x is going to equal -6 because we have to put that negative there. And then 2 times -1. Okay, so if we have 6, actually -6 on top, and then the bottom is also going to be -2, then x is going to be +3. I'm going to go ahead and sketch my line of symmetry right now. Remember, x equals 3 is my line of symmetry. And so I can just go ahead and plot that, draw that on. And that helps me find the center, the middle part of the graph. So the next step in my work here is going to be to find the coordinates of the vertex. I already know that x is equal to 3, and now I'm going to plug in that value into my function up here, and that's going to help me find my y value. So 3 is the x value. I still have to find my y value. So y equals -3 squared plus 6 times 3, because I'm plugging in 3 for every time I see an x, plus 1. Alright, this has to be squared, and then we're going to apply the negative afterwards. So if we square 3, that's 9. We have the negative sign out front, so that's going to be -9 plus 18 plus 1, and then that ends up being 10. So 10 is our y value, and our vertex is 3, 10. So that's going to be important. That's going to be our maximum value on this graph, because remember, it's a downward facing graph based on the fact that we have a negative a value here. And we also need to find the y-intercept, and the y-intercept, again, remember, that's going to have to do with c. It's going to be where the graph hits the y-axis, okay? So c is always just going to be plugged in there, and that's going to be 1 this time. So we're going to take a look at sketching the graph. We already have our line of symmetry, axis of symmetry drawn in there, and so now I can just plot my vertex point, which is at 3, 10, way up here at the top of the graph. And then remember that the y-intercept was 0, 1, and here we go with the 0, 1, that's our y-intercept. Now count the number of units over to the axis of symmetry. It looks like we have 3, and if we go 3 past there, we're going to be right here. Remember, a quadratic graph is always going to be symmetrical. So we're going to make our graph downward facing, and it's going to go through that point there because we know it hits the y-axis at 0, 1. This is our vertex, the top point here. It's our maximum this time because our graph is downward facing. It's not an exact graph. I mean, if we did a table of values, remember, that takes a little bit more work. This question does not ask us to do that, but if we did, we would have a more accurate graph than the one we have here. But it's in this lesson, we're just focusing on finding out the vertex, the y-intercept, the axis of symmetry, things like that. So we're looking at focusing on a couple of different things than creating that table of values like we did in the previous one. So we're not doing that this time, but keep in mind that's a way to get a more perfect graph. And the final thing for you to do on your notes is these two on your own questions. I've given you two functions, and I would like you to answer the 5 questions that I've gone through with you in this case, but you do not have to graph these, so that's why you don't see a piece of graph paper here. I just want you to identify A, B, and C from each of the functions, tell whether the graph opens up or down, find the axis of symmetry using the little formula that I've given you, and find the vertex. Of course, remember that's going to be an x and a y value. It's an ordered pair. And finding the y-intercept using C. Okay, and if you did come up with any questions, if something doesn't seem quite right, or if you're having a little bit of a difficulty understanding something, please write down any questions that you have, and let's answer those in class.